Hello and welcome to the AP Calculus Section 3.6 homework solutions. We are going to be working these 5 problems starting on page 203. It's going to be a pretty long video. These problems are pretty involved. So let's go ahead and start by just want to take a look at this. It's not a fraction. There's no denominator. So we have no vertical asymptote and no horizontal asymptote. So we've already built a little bit of credit there. So let's start with the first derivative test. Y prime is 3x squared minus 6x. I'm going to set that equal to 0. Let's factor out a 3x, and we would have x minus 2 equals 0. So our critical points are going to be at x equals 0. So 0, plug in a 0 right there. That make the whole thing 0, and 2. Okay, so I don't worry about giving the y value of those, but it's x equals 0. Let's give myself a little more room here. X equals, let's see. Critical point, x equals 0 and 2. Okay, so let's do a sine line from negative infinity to infinity. Left to right, we'll put a 0, then a 2. Let's plug in a negative 1 here. That would be a negative times a negative, which is positive. A good one to plug in between 0 and 2 is 1, so that would be 3 times negative 1, which is negative. And then greater than 2, let's say 10, that'd be 30 times 8, that's positive. So we're increasing until we get to 0, decreasing until 2, and then increasing again after 2. So we do have a max and a min. So let's go ahead and write this down. Increasing from negative infinity to 0, and also from 2 to infinity. And we're decreasing from 0 to 2. Okay, we have a max at the point 0, and then when we plug that back in to the original equation, plug in a 0, it would be 3. So 0, 3. And then we have a minimum if we plug in 2 to the original equation. That'd be 8 minus 12 plus 3, so that would be negative 1. But if you don't like doing that in your head, just put it in your calculator. All right, second derivative. I'm going to take the second derivative, like to start up here. That's going to be 6x minus 6. Set that equal to 0. So we have an inflection point at x equals 1. Okay, that'd make that 0. So I'm going to go ahead. I like to write everything down as I come to the conclusion. So 1, I'm going to plug in a 1. That'd be 1 minus 3. Negative 2 plus 3 is 1. So it'd be at 1, 1. Let's do our sine line. Got a 1. To the left of 1 would be 0. So that would be negative. Concave down. And then to the right of 1, let's say 10. Anything that's going to be positive. So that is concave up. Okay, so I have concave down from negative infinity to 1, and concave up from 1 to infinity. All right, so you've gathered all of your information. You've gotten a lot of partial credit. Now we're going to have to draw a rough sketch of the graph. Okay, what I like to plot is a maximum, so 0, 3, let's say that's, I don't know, right there. And then a minimum over 2 and down 1, so something like that. We are increasing from negative infinity to 0, so something like that. We are also concave down. We're concave down until we get to 1. Our inflection point is at the point 1, 1. So I'm going to plot that. We know we stay concave down until there. And then it flips to concave up. It's decreasing. Now, I'm making it a little more obvious there than probably the curve is probably a little gentler than that. And then we are increasing at 2. So this is 2, this is 0, and we start to increase. So there you go. Looks pretty good. So number 7 is in the books. Okay, let's raise the stakes here. So each one gets a little more tedious until we get to number 34, and then that one's not too bad. Okay, number 13. We have y is equal to 3x to the 4th plus 4x cubed. Okay, so not a fraction, so there's no vertical asymptote, no horizontal asymptote. So first derivative test, y prime is equal to 4 times 3, 12x cubed plus 12x squared. Set that equal to 0. So I am going to factor out a 12x squared, and I would have x plus 1. So my critical points occur at x equals 0, if you plug in a 0, and negative 1. So I'm going to draw my sine line. Next to this factored version, it's kind of the easiest one to eyeball. Let's go ahead and write in our critical points. X equals negative 1 and 0. Don't accidentally put 0 first. I've had students do that. All right, negative 1. So let's try negative 2. Well, this is going to be positive because you're squaring it. Negative 2 plus 1 is negative. Positive times a negative is negative. And then negative a half, that'd be positive times positive, so positive. And greater than 0 is going to be positive. So we are decreasing till we get to there, then increasing. And there's no vertical asymptote, so we probably have a horizontal spot in the graph. We do have a minimum. So there's no max. We do have a minimum. It's at the point negative 1. And if we plug in negative 1, that would be 3 plus negative 4. So it's at negative 1, negative 1. We are decreasing from negative infinity to negative 1. And then we are increasing from negative 1 to 0, and then it hits a flat spot in the graph, and then 0 to infinity. Okay, so now let's do the second derivative test. Y double prime. So I'm going to take the derivative from here. 3 times 12 is 36. X squared plus 24x. Set that equal to 0. We could factor out a 12x, and I would have 3x plus 2. equals 0. So I have an inflection point at x equals 0 for that one. And then negative 2/3 also, because 3 times negative 2/3 would be negative 2, right? All right, so if you have a hard time doing that just by eyeballing it, set this parenthesis equal to 0 and just do the algebra and solve. Okay, let's go ahead and write that in. Our inflection points occur at 0, and then if I plug 0 in, I've got 0 here. And also negative 2/3. And if you plug in negative 2/3, let me show you how to get this. Let's see if we can get this in a fraction. Let me just take a moment here. So I'm going to do 3 times left parenthesis negative 2 divided by 3 right parentheses, raise that to the 4th power, and then right arrow that, plus 4 times left parentheses negative 2 divided by 3, close the parenthesis, raise that to the 3rd power. All right, so you've got a decimal, but if you want to get that into a fraction, then go to math, and the very first one is frac. I hope you can see that, F-R-A-C, and then it answer answer frac, and it gives you negative 16/27. So you can do it in decimal and then change it to the fraction there. Okay, but I digress. That may come in handy for you someday. Okay, so you've got the inflection points. Let's do our sine line for the second derivative. I'd like to do it negative 2/3 right next to the factored version and 0. Okay, I'm going to pick negative 1, so that'd be a negative times a negative, so positive. And then I'm going to do negative, in between there, I would like do negative 1/2 would work. So that'd be negative times positive, so that's negative. And then let's pick a 1, that'd be positive, positive. Okay, and if you're struggling with that, again, you can use your calculator to plug those numbers in there. Okay, so we are concave up here, concave up, concave down, and then concave up again. So we're going to put concave up from, of course, this is negative infinity to infinity. So negative infinity, so negative 2/3. All right, and then from 0 to infinity. And then we are concave down from negative 2/3 to 0. Wow. So that one was kind of in-depth with all the fractions, but you can do it. Just be careful. Let's draw a graph. A little bit slanty there. We're going to go with it. Okay, I'd like to plot my minimum at negative 1, negative 1. Let's say that's about right there. We have some inflection points, so I want to plot one of those is at 0, 0. Right there in the middle, and then negative 2/3, negative 16/27. So probably something like that. Okay, it's just a rough sketch. So we are decreasing until we get to negative 1 here. And we're also concave up. And then we're concave down and increasing. So we're kind of curving back that way. See how that's a little bit concave down? And then we're concave up again, so it flattens out right there. And we increase. So that's a pretty decent rough sketch. And there you have it. Okay, we are 2/5 done. Haven't had any asymptotes yet. I doubt, though, that we're going to be able to go forever without any asymptotes. All right, number 18. Another one with no asymptotes. So on this one, we have y is equal to x minus 1 to the 5th. So not a fraction, so no horizontal asymptote, no vertical asymptote. Let's do the first derivative test. Y prime is equal to 5. Using the chain rule, times x minus 1 to the 4th, times the derivative of the inner function, that's just 1. All right, going to set that equal to 0. So I can eyeball this. Our critical point occurs at x equals 1. All right, put a 1 in there. You're going to have 5 times 0. So our critical point is at x equals 1. Okay. Let's do a sine line. One, negative infinity to positive infinity. All right, let's go something to the left of 1. How about 0? That's going to end up being negative 1, but to the 4th power, make it positive. So it is positive. And to the right, 2 minus 1. Let's say a 2. 2 minus 1. That's positive. We don't have an asymptote there. All right, so we do have, though, a flattening out point. We are never decreasing, so our decreasing intervals would be none. Increasing would be from negative infinity to 1 and 1 to infinity. All right, and the reason I don't say negative infinity to infinity is because we do have a horizontal spot at a horizontal tangent line, so horizontal spot at x equals 1. Okay, no max and no min, so a lot less calculating on this one, right? Okay, the second derivative test, I'm going to have 20, so 4 times 5, 20 times x minus 1 to the 3rd times 1, the derivative of the what's inside the parentheses. Set that equal to 0, and I think I can eyeball this one. We have an inflection point at x equals 1, because that would make it 0. So our inflection point occurs at 1, 0. So plug back into the original equation. 1 minus 1 is 0. Let's do a sine line. Negative infinity to infinity. Figure out the concavity here. We've got a 1. To the left of 1, my favorite is 0. Negative 1 cubed is negative 1, so that's going to be negative. So we are concave down. And greater than 1, the whole thing is going to be positive, so that's concave up. Okay, let's write all that down. Concave down from negative infinity to 1. Concave up from 1 to infinity. Okay, now finally we can draw a rough sketch here. No max or min to plot. We have an inflection point at the point 1, 0, so that's going to be, let's say that's right there, 1, 0. Okay, so it is concave down, but increasing until we get to this point here. So probably something like that. It flattens out for a moment, and then it starts increasing again, but it curves, has a concave upward curve instead of concave down. All right. No asymptotes, so that one's pretty simple. You could figure out where it crosses the y-axis if you needed to be a little more accurate there. Okay, so in that case, you would just set x equal to 0, so that would be, it would cross at negative 1. So I actually drew that pretty good. All right, 2 more. Now the tedious one is number 29. So let's just take a deep breath, not get in a hurry. we're going to have to use probably the quotient rule. So we have x squared over x squared plus 3. Okay, we got a fraction here. We have a horizontal asymptote. We have a tie in the powers, x squared. Don't worry about the 3 here. It's the highest power. It's a tie. The coefficients are 1. So at y equals 1. As far as vertical asymptote goes, you can't make the bottom 0 because you square the x. So any number you put in is going to become positive. So there is no vertical asymptote. We do have a horizontal asymptote. Okay, let's take the first derivative. The bottom, x squared plus 3, times the derivative of the top, 2x, minus the top, x squared, times the derivative of the bottom, 2x, all over the bottom squared. Now I'm going to try. So where this function is 0 is where the top is equal to 0. So I'm going to clean up the top. The bottom is never going to be 0. So let's clean up the top. So I would have, distributing the 2x cubed plus 6x minus 2x cubed. So the top of this just ends up being 6x because those cancel. So I have 6x over x squared plus 3 squared. Where does that equal to 0? Well, it's when x is equal to 0. All right, so we have a critical point at x equals 0. Now I'm going to do the sign line down here because I'm just going to be plugging into 6x, right? Because the bottom's always positive. So put a 0 to the left of 0, it's going to be negative. To the right would be positive, right? If I plug in a -1, it'd be -6, a +1, +6. So we're coming down, then going back up here. So we do have a minimum, no max. Make sure to write that in, get those points. We have a minimum at 0, 0. So it'd be 0 over 3. So 0, 0. We are decreasing from -infinity to 0 and increasing from 0 to infinity. All right. Not so bad. All right, I've got to take this right here and take the derivative of it to get y double prime. So it's going to be the bottom, x squared plus 3 all squared. Okay, x squared plus 3 all squared times the derivative of the top, which is 6, which I'm just going to go ahead and put that out front. Minus the top, 6x, times the derivative of the bottom. Okay, so that's times 2 times x squared plus 3 to the first times 2x, right, times the derivative of x squared plus 3. All over x squared plus 3, the bottom squared, so that would be to the 4th. Now again, all I'm really worried about is the top. Where is the top 0? Because the bottom's never going to be 0. So I have 6 times x squared plus 3, all squared, minus 24x squared times x squared plus 3 all over x squared plus 3 to the 4th. All right, goodness. Okay, I can get rid of, so each term has an x squared plus 3, right? So we can totally get rid of that one. Take this to the third power and get rid of that and make it to the first power. All right, so that's going to be 6 times x squared plus 3 minus 24x squared over x squared plus 3 cubed. Now again, because it's x squared, the bottom's never going to be it's never going to be 0, never going to be negative even. Okay, so I really just care about the top. So that's going to be 6x squared plus 18 minus 24x squared. That's the top over x squared plus 3 all cubed. So that would be 18 minus 18x squared. And since the bottom's never 0, I just want to see where that's 0. I could factor out of 18. And I got 1 minus x squared. So we have an inflection point at x equals, it's when it's 1, right? When this x squared term is 1. So plus or minus 1. Negative 1 squared would be 1. Positive 1 squared would be 1. So again, just worried about the top. So I have inflection points at negative 1, and then I plug in negative 1 up here to the original, and that would be 1 over 4, so negative 1 1/4, and positive 1 1/4. Holy moly. Okay, so I've got the inflection points. So let's, I'm going to erase all this. Well, I could go ahead and do the sine line, and then let's see if I can get it on here. All right, I'm going to do the sine line right here. So I've got negative 1 and 1. All right, let's put in, I don't know, negative 10. So it would be 18 minus 180. So that's going to be negative. Let's put in 0. That would be 18 times 1. So that's positive. And then let's put in, I don't know, 2. Okay, so 1 minus 2 squared, that's going to be negative. Right? So 18 times a negative is negative. Okay, so we're concave up here, concave down, concave down. All right, now I'm going to erase this so I can... So I hope you've written all this down. Okay, I'm going to get rid of all this. I'm going to leave the sine line there. And I'll put the graph over here. So we are concave down from negative infinity to negative 1. And from 1 to infinity. And we are concave up from negative 1 to 1. Brilliant. All right, this is a booger. Okay, let's put in the horizontal asymptote of y equals 1. Like that. Okay, so that's at 1. I'll just put a 1 right there. So got the horizontal asymptote. We have a minimum at 0, 0, so right there. Then we have inflection points at negative 1, so back here, let's say about based on how, about right that, at 1/4, so let's say right there. And positive 1, 1/4. So it's concave up for that. But concave down then, so it goes concave down. Like so, it's decreasing and concave down. Then when it hits this inflection point at negative 1, it becomes concave up till it gets to 1. and then goes concave down again, but it starts increasing from 0 to infinity. So kind of looks kind of like a bird, doesn't it? Wow, what a problem. If you get one of those on a test, one that bad on a test, then you know your professor's he's being a little mean. All right, good a problem though. If you understand that one, you ought to be able to handle just about anything you could get. Okay, goodness. Earned my money today. Let's try the last one on this homework, number 34. Why did I assign so much homework? Okay, 34. We have f of x is equal to x plus 2 over x. This looks a little easier to deal with. All right. It looks like we have a horizontal asymptote at y equals 1, right? Because it's x over x. If you take the limit as x approaches infinity, it's at 1. And we also have, finally, we have a vertical asymptote at x equals 0 because 0 makes it undefined. Okay, let's take the first derivative, f prime of x, bottom, x times the derivative of the top, that's 1, minus the top, x plus 2. See me put it in parentheses there? So I distribute the entire top. So bottom times the derivative of the top, which is 1, minus the top, x plus 2, put it in parentheses, times the derivative of the bottom, which is 1, all over the bottom, squared. X's cancel and you have negative 2 over x squared. Now that is never going to be 0. So you can't set that equal to 0 and solve. There's a vertical asymptote at x equals 0. However, we do have a critical point where there's a vertical asymptote, okay? Because that critical point, negative 2 over x squared, occurs where the denominator is 0 also. So we have a critical point at x equals 0. I'm going to do the sign line right underneath here. And I like to go ahead and mark that it's a vertical asymptote. So if any number you put on the bottom is going to be positive because you're squaring it. So you're going to have a negative over a positive either way. Negative over a positive is always negative. So this function is always decreasing. So we have no max. There's no minimum also. Those arrows don't come together. Always decreasing. So increasing, none. We are decreasing from, I always forget that, don't I? Negative infinity to 0 till you hit the asymptote, and then again from 0 to positive infinity. You can't include 0, so you can't say negative infinity to infinity because there's an asymptote there blocking you at 0. Okay, we got through all that pretty quick, so this is going a lot faster than number 29. Okay, so f double prime of x. So I'm going to rewrite f prime of x here. Rewrite it as negative 2x to the minus 2. So f double prime of x, the second derivative, would be 4x to the minus 3. So that's 4 over x cubed, and that is never going to be 0, is it? But you do have an inflection point at x equals 0, or at least a potential one that we have to test. Now, if you plug in, you don't get a y value for that inflection point because it is at the asymptote, isn't it? It's where the original function has 0 in the denominator, so we're not going to get a y value, but we can have a change in concavity. So let's test that. Put in a 0. To the left would be negative 4 over, let's say negative 1. 4 over negative 1 is negative. So concave down. 4 over positive 1 is positive. So it would be concave up. So concave down from negative infinity to 0. Concave up from 0 to infinity. Notice I'm not making the obvious to infinity and beyond joke. All right. Okay, let's do a rough graph of this. Now I'm going to go ahead and mark the vertical asymptote. Let's see, there's a vertical asymptote at 0. Put that in red. And we have a horizontal asymptote at y equals 1. So let's call that right there. We're always decreasing. So we can't pierce either of those dashed lines. It's concave down to the left. So the only thing that'll work looks like that. Because if we started this graph up here, you'd pierce the blue dashed line, wouldn't you? So that will work. And then the only other way, the only way it's always decreasing but concave up, the top would look like this. Okay, so start up here, go like this, and you'll never pierce either asymptote. So you might have to think about that. If you'd started that down here, the tail of that arrow would pierce the blue line. Okay, that does it for this homework assignment. Maybe the longest homework solution video I've ever done. But hopefully you didn't need to watch all of it. I'll talk to you next video.